In Lesson 10, we learn about change expressed as a percent. Let's use our model to see what we mean. Here we have a base amount and we have an amount after a change. Now this could be an amount of money that you have, and then after you spend some, you have another amount of money, somewhat less. And then we want to know the change, but not the amount of change, the change as a percent of the base. So let's put some numbers to this as an example. Let's say that you started with $350, and after you spent money, you were left with $200. Now we want to know by what percent did the amount of money that you have change. Well, first we need to calculate the amount of the change. So we take the amount that you have after you spent money minus the amount you started with, and we get negative $150. In this case, the negative amount indicates that you spent money, or that the amount of money that you have went down versus up. Now we calculate the percentage that 150 is of 350. And that turns out to be 42.9%. So the percentage change that took place after you spent money, after you spent this $150, is 42.9%. You have 42.9% less money than you had before. The formula that we use looks like this. You take the amount after the change, subtract the amount before the change, and then you divide by the amount before the change. In this case, we computed 200 minus 350. We divided by 350, and we got negative 0.4286, or negative 42.9%. In example problem number 1, we see that a coat is on sale. The original price is $82, and the sale price is $74.50. And the question is, what is the discount expressed as a percent change? So let's show the amounts on our model. We see that the base price is $82, and that after the change, after the discount on sale, the price is $74.50. Let's use the formula. We use the amount after, which is $74.50, minus the base, which is 82, and divide that by 82. $74.50 minus 82 is $7.50, so that's the amount of the discount, and the percent change is down 9.2%, or approximately 9%. In problem number 2, we look at change as a percent when the change is a positive change. So in this case, a store buys an electric guitar for $295 and then marks the price up to $340. We want to know what the markup is expressed as a percent change. Well, here's the change. We can see that it's a positive change, and let's show the amounts. The base amount in this case is $295, and then after the change, the guitar is marked up to $340. I couldn't get Geometer's Sketchpad to get this exact, so we'll just pretend that it's exactly $340, and the computations will be very close. So the base price is $295. After the change, it's $340. So the formula tells us that we take the amount after the markup, in this case $340, minus $295, divide by $295, and we get 0.1527, or 15.3%. So the amount of the change is roughly $45, and the percent change is approximately 15.3%. In problem number 3, we learned how to compute percent error. The percent error is the percent by which an incorrect value is off from the actual correct value. In this case, a decorator estimates that a rug is 5 feet by 8 feet, but it's actually 4 feet by 8 feet. So we want to know what the percent error is in the estimated area. Well, the correct area is 32 square feet, and the incorrect area is 40 square feet. So we want to know what the error is as a percent. Well, the amount of the error is 8 square feet, and let's use the formula. So we take the incorrect value, subtract the correct value, and divide by the correct value. So we use 40 as the incorrect value, minus 32, which is correct, divided by the correct value, and we get 0.25 or 25%. So we say that the percent error is 25%. In problem number 4, we're going to find the minimum and maximum possible dimensions of an object given a possible error in measurement. So let's say that you're framing a poster and you measure the length of the poster as 18.5 inches and your measurement is accurate to the nearest half inch. What are the minimum and maximum possible lengths of the poster? Well, if we look at this pictorially, here's a picture of your ruler, and here's 18 inches and 19 inches, and you measure the poster as 18.5 inches. So if your error is 1/2 an inch, then you could be wrong in either direction. So the area that you're wrong is half of 1/2 an inch below or half of 1/2 an inch above. So those are the possible errors. So let's see how the computation works. To find the minimum possible dimension of this poster, the minimum possible length, you take the measurement that you took, 18.5, and subtract half of the error. So you get 18.5 minus 1/2 over 2, so that's 0.25, and that equals 18.25. So the minimum possible measurement is 18.25. The maximum possible measurement is the measurement that you took, 18.5, plus half of the error. And if you work out that computation, the maximum possible length of the poster based on your error could be 18.75 or 18 3/4 inches. In problem number 5, we're asked to find the greatest possible percent error in the volume of this box. So let's read the problem. The gift box at the right has been measured to the nearest inch. What is the greatest possible percent error in the volume of the box? So there are a lot of steps, so let's break them down. First, we need to find the volume of the box as measured. Next, we're going to find the maximum and minimum possible measurements, and then find the maximum and minimum possible volume. Then we're going to find the amount of the error of each one of those, the maximum and the minimum, and use the greatest of those two to find the percent error. So let's see how that works out. If we measured this box as a length of 6, width of 5, and a height of 12, then the maximum that this could be, given that we measured to the nearest inch, is either a 1/2 inch bigger or a 1/2 inch smaller. So the maximum is 6.5 by 5.5 by 12.5, and the minimum would be 5.5 by 4.5 by 11.5. So now we've found the maximum and minimum measurements. Now let's take a look at computing the volume. The formula for volume is length times width times height. So the measured volume of the box is 6 times 5 times 12, which is 360. The maximum possible is 6.5 times 5.5 times 12.5, that's 446.875. And then the minimum possible is 284.625. That would be 5.5 times 4.5 times 11.5. Now, let's see which one of those two, whether the maximum or the minimum, is farther away from the measured volume. Well, if we subtract the measured volume from the maximum, that's 446.875 minus 360, we find a difference of 86.875. If we find the difference between the measured volume and the minimum volume, we find that that difference is 75.375. So this volume, 86.875, that difference is the biggest one. So now we use that difference to compute the percentage error. Right? So percentage error is going to be this difference, the error, minus the base, 360, divided by 360. That comes out to be negative 0.24, so you could be low. And as a percentage, that's 24%. And it makes sense to express your final answer as a positive percent, since they are asking for the greatest possible percent error. So the solution to number 5 is 24%.